Hello everyone, welcome back. My name is Mr. Kovalt, and in this video I'm going to be going over a couple of example problems involving skewed molecular orbital energy level diagrams. Let's get into this. So in this first problem, we're asked to use a skewed molecular orbital energy level diagram to describe the bonding in the cyanide ion, Cn minus. What is the bond order? Okay, so the bond order, first of all, we want to start with the skewed orbital energy level diagram, molecular orbital energy level diagram here. So here I have carbon and the negative ion for nitrogen. I put the negative sign on the nitrogen because it's more electronegative. You can see that's more electronegative according to the skewed energy level diagram because the more electronegative atom has the atomic orbitals that are lower. So you can see that the 2s atomic orbital for the nitrogen is lower than that for the carbon. Same thing with the 2p and the 2p here and here. So the first thing we want to do is fill up the diagram with the valence electrons. We have 4 valence electrons for the carbon because it's in group 4. So we'll put 1, 2, and then 3, 4. And then nitrogen is in group 5, so it's going to have 5 valence electrons, but it's got a negative there, so that's 1 extra electron, so that's 6 electrons. So we'll put 6 electrons on this side, so spin up, spin down there, and then we got 1, 2, 3, and then 4. Okay, so now we're going to add these electrons. That's a total of 10 electrons. We're going to fill in the molecular orbital diagrams with the 10 electrons, starting with the lowest. So we'll go spin up, spin down there, and then to the next one, spin up, spin down, and then to the next one, spin up, spin down. That's 6. We have 4 more. So then we're going to have spin up, and then spin down, spin down. So that should be 10, 2, 4, 6, 8, 10. Okay, so now that we've filled that in, now we can calculate the bond order. So again, remember, bond order is the number of bonding electrons. Those are going to be the electrons in the molecular orbitals that do not have a star. So those are the bonding molecular electrons. So we have 2 here, we have 2 here, 2 here, 2 here. So that's going to be 2, 4, 6, 8. So that's 8 electrons. So bonding order or bond order is equal to 8 bonding electrons, and we're going to subtract from that the anti-bonding electrons. Those are the electrons you find in the anti-bonding orbitals, which have an asterisk or a star. So we have 2 electrons here that are in the sigma 2s star molecular orbital, and that's all we have. So that's going to be minus 2. We're going to divide all of that by 2. So 8 minus 2 is 6 divided by 2, and that gives us 3. So we are predicting that the Cn, the cyanide molecule or ion, has a triple bond or 3 bonds between the carbon and nitrogen, very similar to the nitrogen molecule N2. Okay, so that's the first problem. Let's go on to the next problem. Stay tuned. Okay, so our next problem is to use a skewed molecular orbital energy diagram to describe the bonding in the perchlorite ion, ClO minus. What is the bond order? So as you can see, I have the same molecular orbital energy level diagram. It's skewed. I have oxygen on this side. I have chlorine on this side. Chlorine is the more electronegative atom, so I gave that one the negative, and you could see that the the atomic orders are lower for the chloride ion than it is for the oxygen atom. And so let's fill in uh, the atomic orbitals with our valence electrons. So oxygen is group 6, so it has 6 valence electrons. So put 2 here, spin up. That leaves 4, so we have spin up, spin up, spin up, and then spin down. So there's our 6 for the oxygen. Chlorine has 7 because it's in group 7. It has a negative charge, so that means it gets 1 more electron, so that's 8. So we're going to fill in 8 here. So we have spin up, spin down. That's 1, 2. And then we have 6 more. Spin up, spin up, spin up, spin down, spin down, spin down. So there's 8. Now we're going to have 8 on this side. We have 6, so that is going to be 14 total. So we're going to fill in the molecular orbital diagram. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we have 11, 12, 13, and 14. Okay, so that part is done. Now all we need to do is calculate the bond order. So once again, bond order is equal to the number of bonding electrons. So here we have 1, 2, 3. Oops, that's not bonding, that's anti-bonding, so we don't want to count that. So we have 1, 2, 3, 4, 5, 6, 7, 8. These are anti-bonding, so we're not going to count those. So that's 8 bonding electrons. Now we want to count the anti-bonding electrons in the anti-bonding molecular orbitals, and we're going to subtract those. So we're going to subtract how many? We have 2 here. That's 1, 2. We have 2 here and 2 here. That's 6. So we're going to subtract out 6. Divide the difference by 2. 8 minus 6 is 2. Divided by 2 gives us 1. So the bond order is 1, meaning that it only has 1 bond between the oxygen and the chlorine, and that fits with what we know from experimentation. And that is it for this video. And I hope you enjoyed these example problems. If these helped you out, then please, by all means, like the video, share the video, hit that like button somewhere over here. Also, do me a favor, help me out. Subscribe to the channel if you haven't already. Click on that notification bell. When you do that, click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a problem or a question you need help with, or a topic you would like me to cover, put that down below. I would love to do that for you. Thanks for joining me, and have a great day.